Thank you, everybody, for joining. My name is Parker, and I'm a product marketing manager here at GitLab for CI/CD, and I'll be helping moderate for the webinar today. Before we get started, you will see a poll pop up here in just a second. There'll be 2 questions, very short, be very helpful and valuable if you could answer those for us and learn a little bit more about why you're here in our audience. We do have Michael from GitLab, our developer evangelist, to talk about securing your CI pipeline. I'm very excited to have you here today, Michael. A little bit of housekeeping for the audience. Please hold your questions until the end. You'll see a Q&A box on the bottom of the Zoom. Please do use that for questions, and we'll have some time for Q&A to address them at the end of the webinar. Of course, if you're experiencing any difficulties, technical difficulties, you can use that chat function to get in touch with either myself or Agnes, the moderators. And we will be recording this presentation today so that you're aware, and we'll have that recording available for all the registrants here in the end. I think that about covers it. So as this poll is finishing up, you'll see one more question, and I am going to hand it right over to you, Michael. Thank you.
Thank you. I'm going to start with a short agenda and a warm welcome also from my side. We are going to do a short introduction about myself, about GitLab. Then we're diving into a little bit about security and CI for today. This involves static application security tests. We're going to have a short look onto secret scanning. Then there's more about container dependency and license scanning. We're also coupling it up or wrapping it up together into security management. And in the end, we'll have a short conclusion and, of course, time for a demo and as well the questions afterwards in that regard. Little bit about myself. I'm Michael. I'm originally from Austria, now living in Germany for some years now. I've joined GitLab around about 4.5 months as a developer evangelist. Which means I'm diving deep into all things development, but also education. I do love open source in every aspect. I need to not work too much, because when you work in your spare time and also at work, it's kind of burnout. So I'm building Lego models in my spare time, and I really enjoy doing that. If you want to reach out to me, you can find me as DNS Michi, it's a German word, the lovely version of Michael, on Twitter, on GitLab, on specific other social media sites. And if you want to learn more about my job, what I do, the Technical Evangelism Handbook covers that as well. But for today, we're going to dive a little deeper into GitLab. You probably know what we do. I just want to highlight specific things. I think I joined GitLab when we were 1,235. Right now we've hit the next mark. The next goal would be 1337 lead. And we're spread around the globe. So remote work is our thing. I'm experiencing that myself. And we're building a great software, which we're using ourselves as well. It's been adopted by 100,000 organizations. We have millions of users, and we have a strong open source community. So I think the last release got 300 merge requests from the wider community, which is super awesome. And it helps build our DevSecOps platform, which involves you create something, you manage it, you want to release it, you want to monitor it, deploy it, test it, and you also care about security after all. And this brings me to what I want to dive in for today. You might have read the DevSecOps report for this year already. Security is shifting left, and we want to kind of know what does shift left mean. So it's something is moving to the left. The main thing about security is it's really hard to really test applications. You need to find a way to do that, and you also need to be aware of doing it, because cyber attacks are going on. Basically, at the very moment we have this webcast, someone might be attempting to exploit your application. The other thing is it's really hard to keep up with everything. So an exploit which has been fixed might be reintroduced because the software change is like doing that again, and you have no way to control that. You might buy an existing application security tool, which is rather expensive, and it's also expensive in the way that you need to integrate it into your technology stack, but also in your culture and your processes. So everyone needs to be aware of that tool. And you also need specific workflows for that. So you need to train your teams working together. And one specific thing, when you want to perform the shift left, so shift left means that developers also care about security, that they adopt a specific security automation in their workflows. You need to combine it in the sense that the dev and the sec are working together as a team. And they don't create any sort of silos, which basically means that everyone says, yeah, it's my own issue, and if you want something, please create an issue, and then I'm like playing ping pong as long as someone else says, well, let's just fix the problem because security matters. How this could look like in a traditional approach, if you have it already, you as a developer are working on the repository, you commit something, continuous integration is running, the merge request happens, and then CD or the deployments happen into a staging, a test environment, and the test environment might have some specific scanner types from the security team. The security team gathers the reports, and based on maybe a weekly report, a daily report, a monthly report, specific issues are created for developers, and the loop continues. So basically, every time you deploy something, there might be an asynchronous security report, and you get a lot of issues. Aside from fixing bugs and creating new features for the software, you also need to fix security vulnerabilities. And sometimes they may just happen. Yeah, at 3 AM in the morning, like the monitoring is sending you an alert. The security team could also like trigger an alert, and some data leak happened, and you need to get up, and it might lead into burnout actually. So what's the idea to prevent that from happening? One thing or one idea is to actually do the shift left, which means within the merge request workflow, the GitLab workflow, whenever you create a merge request, you commit your changes and the CI pipeline is running. Additional CI jobs are being run and doing basically the security scanning or the security testing, even before something is going into a testing environment, a specific review, and you get everything at hand which might influence the security or specific vulnerabilities in your application. So whenever a new vulnerability is detected, it does not hit your master or your production branch. This can look like this basically. From the CI/CD pipeline aspect, this is basically just a part for the CI pipeline right now. You have maybe the stages, prepare, build, and test. And within the test stage, there are additional CI jobs configured. We will check this out later on, how this can look like. And these checks are being run on each commit in each pipeline, and generate reports where we can like do further analysis from and escalate and create issues and so on. This is the main idea about it. And just to see what possibilities we have with GitLab and the secure stage. One thing is classic static application security tests. So we actually want to test our application for known vulnerabilities, and there are potential methods or different methods to be applied. So sometimes you might just pass in a parameter to a function which might be not initialized, or which might not be checked for a specific size, or typically SQL injection, which is just a semicolon and drop table or something like that. This is something you can actually test within static application security scanning. Another thing would be just imagine that you change the file permissions on disk for a temporary file, making it readable for everyone and even writable, which could be a symlink attack, which is pretty common. And another thought could be, for example, buffer memory overflows, where you are not checking for any out of bounds things, and someone else just overflows memory and gets access to a memory address they are not capable of originally, and they do something nasty, and they might get root to your host, or leak some data or something else. This is pretty much black magic if you try to understand it, but you just need to know that it's possible, and you want to prevent it at all costs. The other thing is applications could be vulnerable to cross-site scripting attacks, just like, for example, JavaScript or Node.js, which could mean that they could reuse the user sessions. You could just leak private data, or even like impersonate a specific administrative account and do some further like identity theft or specific other leaks. This is all just bad, and we want to prevent that from happening. Yeah, and the last point on the slide is just to protect against code vulnerabilities on its own. So we're human beings, we make mistakes, and sometimes we don't even know that this could be exploitable unless a security scanner says, oh, this is how it could work, and this is how it can be fixed. An example for SAST could be, for example, setting file permissions in a Python script. So in this example on the right, I'm just opening a file and then changing the mode to 777, which means everyone can do everything. And if I would just like open it later on, an attacker might just like inject something bad, and then my code does whatever the attacker wants to. And the thing is, the SAS scanner can detect that, highlight that, and I also have the possibility to learn more about it and even either dismiss the vulnerability, acknowledge it, resolve it, and create an issue based on that. So confidential issues for further working on that is truly important when dealing with vulnerabilities. Another example would be the memory handling and buffer overflows. This is an example I've written just for the webcast now in C. This basically allocates some memory with mmap, and tries to write into it, and the string copy just doesn't check whether it would be running out of bounds, and the security scanner finds that and even suggests how to solve it with something like SN, printf, and some C-specific functions. And yeah, it's just good to know, because I didn't really expect that it would break at this point. And I learned something new about it. That's one thing. The other considerations about static application security testing and scanning is whenever you need some sort of runtime state, meaning to say you either have a config which changes the overall state of the application, or you have a database backend or data source providing some sort of real-time application, you cannot test that with a static scanner. This is something where you actually need to deploy to your Kubernetes cluster, to your cloud environment, and then run some dynamic scanning, which is a different part of the story. Another thing to consider for static application security scanning is also, as you might have seen before with the buffer overflow, it's not proven that this is really a vulnerability, because just because the static scanner detected it in the line above that this could be a vulnerability doesn't mean it actually is, because 10 lines below we are checking the memory in a different way and we are just making sure that nothing happens. so this, you need to be aware of that this could be a false positive, depending on the design pattern or depending on the way you develop the application. And one other thing to highlight is, next to our ways how we develop software, when some insecure ciphers for TLS or SSL encryption are being used, you cannot detect that. You need to do that at runtime. So with SSL scan tools and other things, or specific cross-site origin things, access control checks, and even more, which requires a runtime state. And last but not least, next to all the things you might have to reconsider when using SAST, is that there are many different tools for different languages. So in the perfect world, there would be just like one backend language and one front-end language. But we have so many programming languages, and each of them has their difficulties and different ways to exploit things, or attackers might exploit it there. So it's really hard to find the best scanning tool out there. Well, it's a challenge, and we are all developers, so challenge accepted. Another thing about a challenge is sometimes it might be convenient to store an SSH key for a test runner in your Git repository, or to use an AWS key in the repository, just the code for testing, and no one really does a review, and the test runner just has your private AWS deployment keys inside, and someone else finds the Git repository, or just even gets access to the code. And yeah, it's basically you need to cycle, or at least redeploy, change the security keys just because the leak was inside the Git repository you shared with the contractor or with the customer. But you don't even know about it, and it goes on and on and on. And secret scanning is one part of GitLab CI security features, which helps you detect that. So in the screenshot on the left, you can see that the AWS key is being detected based on a specific pattern. It's using the Git leaks scanner provider, and SSH keys can also be detected by that. Would be interesting for some specific repositories from my own past where this might be a case. But yeah, it's good to know and good to have it. This can be adopted not only for the current commit or for the current merge request, but you could also say, I want to scan the entire history and detect when this happened. Because oftentimes you need to rewrite the entire history based on that. Yeah. Another thing, we have too many features. Container scanning. Container scanning goes into the portions of we change the way how we deploy applications. So previously we might just like deploy a tarball or use RPM or Debian packages, and modern times are wrapping the applications in a Docker image. And typically we are using a base image for creating our own Docker image where the application resides, and then we deploy it into Kubernetes or some specific other container application cluster. There's a high chance that you're using a vulnerable base image for Docker. So for example, Debian Buster, but its initial release 10.0 and not the current version. Or you might be using the current version, which introduces an actual security vulnerability. Who knows? And reading that manually, following mailing list, reading Twitter and so on does not really help the cause. The idea is, in this case, to also have an additional CI job, which scans for container vulnerabilities and also allows to peek inside the base OS image, meaning to say you get a report, for example, for apt being the package manager having a vulnerability, but could also like be a kernel vulnerability or something else. So basically things in the base image for Linux, for I think Windows is also possible. Anything which happens inside can be compared against the vulnerability library, sorry. And sorry, I'm talking too much today. The main idea is that you don't have to care about the container being vulnerable that much, because automation tells you about it, and you can also create a follow-up issue based on that. This is one of the use cases. Next to containers, your application might be using specific libraries or specific packages, because you don't want to reinvent the wheel. And for Python, you're using packages from PyP, Node.js, NPM, and specific other packages, PHP Composer, for example. And the thing is, for one dependency, it might be controllable or detectable in a way that you detect a specific problem. But sometimes, especially one example would be Ruby gems, there could be recursive dependencies. So one dependency pulls in another and another, and yet you don't control it, but you want to know whether this introduces a vulnerability into your application. And this is where dependency scanning comes in. And you have the possibility to see it in the merge request, but you could also, for example, install it and deploy it into an existing repository and see whether current dependencies have a problem. In the example, we do have Golang on the left. So this is basically, I think I tested a YAML library which has known vulnerabilities. And another example would be if you're developing Python as a web application with Django. There could be, for example, this is using an old version of Django which introduces an SQL injection, and this is not one of the nice things to have. And you get immediate feedback within your merge request that this could be harmful and you shouldn't merge that. On the other side, merge requests typically might not be that insightful, or it might already be merged to production or to the main branch. Therefore, you have the possibility to view the dependency list and especially the vulnerabilities within the GitLab security dashboard. And in this example, Django has an SQL injection in that version, but also weak password recovery mechanism, okay, and specific other vulnerabilities, but the severity is not critical, but high and needs some, you need to review it, whether it affects your production system. This is one thing. And yeah, I knew it. I forgot one thing. License scanning. License scanning from a security perspective could have implications if they actually match your application or your corporate requirement. So sometimes it's you cannot really use open source libraries or bundles which are using the WTF license, for example. Sometimes it's forbidden to use GPL version 2. One example would be if you're developing a C++ application and linking a binary, the Apache license is not compatible with GPL version 2. So you have a problem with open source licenses, and this puts your application at risk and also your product, because with legal and other things. And for some reason, you could also just have a company policy to, for example, only allow open source licenses, which rules out specific others. And you have the possibility with GitLab to define certain license compliance policies and be alarmed or get a notice on the merge request whenever a new license would be introduced into your application. Okay. And last but not least, security management is also important. Because now we kind of have changed the typical workflow and the security has shifted left. So we as developers get direct feedback from our security testing in the pipeline. We can actually deal with any reported vulnerabilities and immediately fix that, hopefully. And our security team also gains insights into that. Just because they get a security dashboard overview, they can see all the vulnerabilities at a global level or just per project. And also do sort of like audits and escalate specific vulnerabilities, because if it's just critical or high, it might hit a specific use case, or not a use case, a specific problem case, and an issue with an escalation level of super important, let's call it like that, needs to be raised and being tracked down, and don't care about features or bug fixes right now. We need to fix the vulnerability. Could look like this. Basically getting an overview about the numbers. You can sort by severity or filter by severity. Get more details when clicking on the issues or the vulnerability in the listing. And once you've created an issue for escalating the vulnerability, this is the overview, and one can work further on that. So the security team also is happy now. Let's just see. Now we're making ourselves a little more happy. I'm just changing over here for my demo. So what I've done basically for the demo for creating an environment, I've said I want to create a mono repository just for the backend and the front end. So it's using different source code. And the main idea is, I want to build it. So I have a Docker file which builds the application, does something with it. I want to run some tests. And for convenience, I've also pushed in an SSH key. And this is basically how it looks like. The Docker file uses an old Debian Docker image, which hopefully triggers our security scanner. The Docker image is being built and then later on used to build the C application. The C application is being done or implemented in the backend. So this is basically just some demo code which like does something and says hello, and might introduce a vulnerability. I think over here, maybe we can just check that out later on. This is the backend. So there's a make file to compile it actually, because I'm too lazy to remember the GCC flags. And for the front end, I've decided to go for Python, which is using a requirements txt file, fetching in Django as an application, and the code kind of like, it's a little made up, it's a little boring, but it just does something and also runs the front-end server. This is basically how I would start implementing it. And let's just say I was importing that from a colleague, or maybe even got the code from a customer because they need a maintainer, and I need to look into that and say, hey, I actually want to analyze that. The thing I didn't show you yet is how everything is configured in GitLab CI. this is basically an iteration I did. So the repository is public, so everyone can just follow later on what I did. The thing is, I would recommend to start with including one of the templates, for example, SAST, so the static application security testing template, and just use that. You could also go for auto DevOps and just deploy the opinionated templates for you. If you want to explore it and learn more about it, I would recommend to play around with the template includes. And there's also the way, which is described in the documentation, you could override them. So specific variables can be set for debugging. You can export specific reports as an artifact to debug it if you want to analyze it. But by default, you don't need it. I tried to play around with it, and I would guess it took me like 30 minutes or 1 hour to have my first success based on that. The prepare Docker and build backend are just normal jobs. This is for building the Docker image and pushing it to the registry. And this actually builds the C code with using the previously created Docker image. So now, how does this look like for security or in our security dashboard? Loads a little, and I have a really highly insecure repository right now. One thing is that our security scanners detected that there's an SSH private key. So when I click on that, I get all the information which has been detected. It tells me the location. So, okay, that's something I should delete. And I also have the possibility to say, well, I want to dismiss this. I want to confirm it or mark it as resolved. I can also create an issue based on that, which automatically creates a confidential issue, includes all the details, and then I just assign it to myself and just keep working as I used to work with GitLab, with issue management, with release planning, with priorities, with reviews and other things, and just treat it as an issue to work with. The next thing in our security dashboard would be, for example, because right now we have analyzed some secrets, and as you can see, the issue is linked there. We have the dependency scanning, which detected the SQL injection in Django. This is super nice. And container scanning detected some other parts. And with the possibility, for example, to say, I only want to see critical vulnerabilities right now. So the list is a little shorter. And I also might have the thing that I have some unknown severities, for example, and I want to just remove them from the list or analyze what's going on. And this is, for example, one from my C backend, where the file name arguments can be okay, that's the one with the symlink attack. Let's just go over there, because the nice thing is it also marks the line. And in this case, I'm opening the file, reading something, and I'm using a change mode also. It tries to tell me it could be something going on if you proceed any further over here. This is one thing. And another thing is, so basically this is the compliance I'm having. So in my main repository, if I have a merge request or I want to add something, and in this example, I'm adding a new front-end connection method for testing. And I'm just waiting as long as the security scanning is loaded. And it says, hey, I found a critical severity, critical vulnerability for you. Probably we should just look into that. Could use the full report or just expand it. And it says our static application security testing detected a password in an URL. So let's just see what it is. ID password in URL, interesting. And the most interesting one is, where did I introduce that? And I created a connect method which uses the username and the password within the URL, separated with a colon and the @ This is discouraged, but you can use it, and the scanner automatically detects that and lets you know about it. The security scanner also detects something like this, like the AWS key based on specific patterns. And I've researched a little about the scanners myself, so I was reading the source code. They're using a long list of pattern detections for specific other types of credentials and keys, not only AWS and SSH and others. Yeah, that's basically about it. What else can I show? I think that's the thing about the demo right now. Might come back to that later on. So what's next after this long brain dump and things to try out right now after the webcast? I would say we are shifting left in our CI workflows, but we need adoption. We need to think about it. The whole feature set for the secure stage can be quite overwhelming. So I would recommend to start with one feature and see whether static application security tests are the way to go, or maybe just start with secret scanning. Go ahead with container license and dependency scanning. Figure out which security checks work, because sometimes there might be false positives or things which don't work for you. And also integrate that into your CI workflows, because when it's automated, it might avoid any on-call alerts at night. And the other one, or the other action, would be to define workflows for security management. So you need to define the directly responsible persons or teams who should be dealing with security vulnerabilities. So be it either the developer or the security team or the ops team, or just a single person, or just someone assigned to it and responsible, with issue creation and escalation in any case private data is leaked, or needs just an immediate analysis, post-mortem security report, as CVE. GitLab is a CNA since, I think, 13.0. So it should become even more easier with GitLab to create a CVE in the future. And once you've mastered the CI security part, so continuous integration security, the CD part, so CD security with either deployment or delivery, should be mastered with dynamic application security testing, threat monitoring, web application firewalls, even more kind of overlaps with monitoring into your Kubernetes cluster or deployments, combining it with Terraform, combining it with everything. Just as a short conclusion, make your life as easy as possible, and sleep safe without worrying too much about security problems. That's the thing. And with that, I've put you some links for the documentation and also the website to learn more about it. Thanks for your attention. Hope you liked it. And now I'm handing over to Parker for the questions.
Thank you, Michael. That was awesome. And so if you do have some questions, feel free to use the Q&A button down at the bottom of the Zoom. We have one right here, and then a couple others that are coming in. So I'll start with the first one. When critical issues are found, can we fail the pipeline and prevent developers from being able to build or promote the image?
I think I don't know exactly whether we could fail the pipeline itself because it's providing the report. So it's basically the same as using a unit test as a report. You can change your project settings in a way that it disallows the merge when it detects a security issue. So the merge button is grayed out then. And with you need to resolve the security vulnerability before the final review happens. It gets approved and then merged to the main branch and then later on deployed to production. I hope this answers the question. I can try to look up. I think it should be somewhere in the documentation. I just don't have it at hand right now.
Cool, thank you. Another one that came in, will SAST be available in the community edition someday? And I can jump on that one, Michael. I'm not sure, right? I think a lot of our features around security are in the ultimate and gold tier, but you never know, right? That's a product decision that would be a TBD there. And then the next one, what about DAST functionality, dynamic testing? Does that address the use case of scanning the code before commit?
No. Scanning the code before commit would mean that you either have a local test environment where you just a commit defines a current state. You say whether it works or not. So kind of you need the commit. But you're not, how to say that, you're developing everything in a feature branch or fixed branch. And you iterate based on you add a backend feature, you add more, and at some point you say, hey, now it's finished. I want to, for example, have it deployed to your testing environment, or the pipeline just does it for you. And this is the point where everything gets tested, and at some later point you decide you want to squash the commits and say it's just not just like the 10 I tried to develop the feature based upon. I just want to have it a single feature commit based on your definitions of the workflow. So you basically need the commits in that regard. You also want to know from the commit history which commit introduced a vulnerability or decreased application performance. This is kind of monitoring, different story, but still it's important to have the commit. If you want to test something before a commit happens, I think you're bound either to a local environment or you have some sort of, you're syncing your code from your local environment, or you just have it somewhere in the cloud and you test it there. But I personally wouldn't really recommend it, but it's my personal opinion, because a commit doesn't really hurt if you're working in your own feature branch, maybe even with your colleagues, because you can always sort of rebase, squash, make it beautiful later on. Okay.
Awesome. And it looks like there aren't any more questions coming in right now. Okay, well, we do have one. How will we get the slides and recording? Agnes, I believe you'll be sending out a follow-up email, correct, with all that information?
Correct. We will be sending the a follow-up email in the next few days with slides and recording to all the attendees.
Yeah, and
Awesome.
I will also make sure that the repository is in there. If you're fast, you can just go to my namespace and look for it. It's public. If you want to try it out now, just fork it and play around with it. Just keep in mind that you need to have I think it's an ultimate version to try everything within the security scanning.
Awesome. Well, if we don't have any more questions, I think we can wrap it up here today. And thank you again, everyone, for joining. I hope you enjoyed the content. Michael, fantastic job as always. And thanks.
Thank you.